Hi, my name is Jaromir. I work at Trend Micro as cyber threat researcher, and in this presentation, we will show the results of our investigation related to abusing third-party cloud services in targeted attacks. So this is the outline of our presentation. So first, there's introduction. Then we will compare two types of malware infrastructures, custom-based and cloud-based. And then we will show a few selected APT cases which we investigated in the past. So now let's go for the introduction. So the abusing cloud services is not something totally new. It has been discovered or it has been seen in the past. However, in this talk, we will focus on cloud abuse, specifically in context of targeted attacks that we investigated. So our goal is to show real examples and real scenarios of cloud service abuse, and also for us as defenders, what it means for us, how we can leverage or how we can take advantage of this approach. So what is the custom malware infrastructure? So this infrastructure is developed and maintained by threat actors. So it's costly because threat actors needs to register domain names, pay for server hosting. There are some another tasks which need to be done, like implementation and testing of the communication protocol, developing backend CNC server scripts, and so on and so on and so on. It has many disadvantages because for us as researchers, it's easier to block or monitor one particular domain or IP address if we know it's related to some malware campaign. There is higher probability of flaws and mistakes in communication protocol. It's more difficult to make the service reliable in real conditions. There can be server outages and so on. But it has one advantage that malware developers can implement whatever idea they want. They are pretty much not limited by anything. On the other hand, cloud malware infrastructure is developed, maintained, and operated by a knowledgeable third party. It's usually a company running this service. So it's cheaper, in many cases for free. It has APIs, which is quite much easier to use this service. It's much more reliable, and it's harder to block, monitor, or seize because these services are mostly used for legitimate purposes, and these malicious purposes is just small fraction of the usage. And as a disadvantage for malware developers is that they are constrained by the features provided by the cloud service providers. Now, after a very short introduction, we will show few selected APT cases which we investigated in the past. So we start with one group called Patchwork. It is a group or threat actor based in South Asia. And every time I mention some threat actor, I will show you this map. And in this map, there are countries in red which have been targeted. So as you can see, threat actor is based in South Asia and mostly targeting Asian countries. Plus, there have been some cases for targeting United States. The most interesting backdoor which was used by this Patchwork group is called Bad News. And it mixes and uses a mix of both alternatives. So we have malware, which first sends GET request to one of several cloud services. As you can see there, Feed43, GitHub, WordPress. Then this service responds with encrypted CNC configuration. This configuration gets decrypted. Malware gets the real CNC server, then it can connect to it. So this is what we find when analyzing the malicious binaries. So there are usually some encoded strings, like in this case, starting with UUQT, semicolon, after subtracting constant value 0x01 from each character. We get these URL addresses, as you can see below, like linking to GitHub, user content, feed43, web RSS, WordPress. Then when malware, or even when we open any of these websites in the web browser, we can see a long string in the middle. This long string is base64 encoded. And after we decode it, we need to use some encryption or decryption. So for decrypting, there have been like different approaches, either using rotation and XOR functions, or even like one more layer using blowfish encryption. So after decrypting, we get a result. One of the abused services in this case was GitHub, and GitHub gives us ability to see the history, see the changes which happen to a given file. So we can see that in one of these repositories, we have a file called xml.xml, and we can see the history. So you can see on March 6, there have been this domain. On the March 8, there have been 2 updates with the same IP address. So they keep updating CNC just by pushing new xml.xml file in a given repository. Also, GitHub gives us the possibility to search for a given file name. So when searching for xml.xml file, we have found 64 different examples. So this is one way how we can more easier track these campaigns if they're using different names or different projects, but with the same naming conventions like xml.xml. Let's continue with another threat actor. This one is called DRBControl. As you can see in the map, it's targeting countries in Southeast Asia. So first we will start with describing type 1 malware. So in this case, malware uses standard CNC channel, which it uses for receiving commands. If necessary, it uploads computer information to its own directory in this cloud service. There is also one more possibility, that it looks for a file with a given file name bin.asc, and this file gets loaded and executed in memory. So if threat actor wants to send another backdoor, which we will see in the next slide, they simply put file with name bin.asc in the chosen directory, and it waits for the backdoor to load it and execute it. So this is a description of type number 1 malware. Then we will describe the backdoor itself. So this backdoor, it usually writes some heartbeat file with this seemingly random name. Then if threat actor wants to execute some commands, then puts them in the file with this name. Then it gets read by malware, gets executed. The result is written to another file, and this another file is then loaded by the malware operator, and they can see the result of executed command. So for us as researchers, it's important to reverse engineer the piece of malware. We can see in the beginning, very important is API key, which malware later uses for uploading files or downloading this bin.asc file. Also, if we have this API key, it's very handy to use Python, because almost every cloud service has API and they have libraries in Python. So if we are researching this threat actor and we have API key, we can read the documentation and we can, for example, see that there is a function called files_list_folder, and it lists folders in given directory. So we can write our own scripts for collecting some information. So after collecting the information or using these scripts for collecting information, we could find following information, like what post-exploitation tools have been used, what commands have been executed by attackers, who were some victims, what information is attacker after. And we also found new command and control servers. And this is the statistics which we could make based on the previous research. So as you can see in the left, threat attacker is mostly interested in listing files and running commands, so likely espionage. And on the right, there are some commands executed via cmd/c command, and they are usually for collecting the information like task list, system information, network statistics. Let's continue with another threat actor. This one is called Confucius. As you can see in the map, it targets the country of Pakistan. So Confucius has one interesting stealer called pcloud. It's a stealer which searches for files with given extensions, and if found, they're uploaded to the pcloud cloud storage. It's very similar to Dropbox. It also has some APIs. It has Python libraries. But there's like one difference. For this pcloud, we didn't have API key, we had credentials, name and password. And as you can see in this screenshot, it's very simple. In just 3 lines, you can list all the files in given directory. So we simply reverse engineer the malware. We find the credentials, and we can use these credentials to log in and see what threat actors left there. There is possibility to restore files. So if some files have been deleted or moved to trash, we can restore them. And also, when threat actor or attacker was testing this piece of malware, they infected their own machine and tested it on this machine. And we found like some interesting files likely written by the attackers. So in this document, we can see on the left is the name, or in the column is the name of the malware. And each column has the result when this malware was run in the machine with given antivirus solutions. So they were testing the antiviruses, and they were seeing like which malware is detected and which is not. And also in one more document, there have been like cases of infected machines and their IP addresses. And here there was even the note that the country was targeting mainly Pakistan, but there was like one case when they for some reason targeted or infected one machine in India. So these will be like documents which we managed to recover belonging to the attackers. Also from Confucius, we will talk about TweetyChat, which is in this case Android chat application. It's backdoored, and again it uses mixed approach. So first it registers to standard CNC server. It sends commands, and one of these commands is updating AWS credentials. And these credentials are used for uploading stored files to AWS. Smaller pieces of information like SMSs, contacts, or call logs are uploaded to the traditional CNC server. So for this purpose, we need 2 keys, AWS key and access key and secret key. And they are uploaded through Google Cloud Messaging or Firebase Cloud Messaging. So by simply reverse engineering the malware, we cannot discover these keys. And we didn't have them when analyzing this malware. This piece of code shows the message receiver from Google Cloud or Firebase, and code below is the piece of code for putting object request, which uploads the new object to Amazon S3 bucket. Even though we did not have access to the cloud service, we still found access to the server itself, to the traditional CNC server itself. And in this server, we have seen running several services. So you can see the service for file structure backup, audio service, SMS call logs, call log request, and so on. And again, in this case, operators were testing malware on their own devices. And we have seen this kind of screenshot. There was like a mobile number, and this mobile number helped us to find some person in social media. So at least we can see that in this case, the threat actor is interested in someone working in army or army related, because you can see that this person works at Pakistan Air Force. Let's continue with another very interesting threat actor. It's called MuddyWater. It's based in Middle East, and it mainly targets countries in Middle East. The first malware we analyzed was a mobile application which uses Telegram for exfiltration. So again, the beginning is similar to the previous cases, the registration and receiving commands from traditional CNC server. However, stolen files are uploaded to Telegram channel. In the screenshot up, there is the code responsible for creating the request to the Telegram channel. So you can see api.telegram.org followed by token followed by method name. Method name in this case is called send message. This piece of code is called process command, and you can see there are several cases, and each case is when it is run, it does different functions. So you can see get system info, get smart call log, taking screenshots, sending SMS. If malware operator for some reason loses the access to the traditional CNC server, there is still one feature that once a day all data are collected from the infected mobile device and sent to Telegram channel. So you can see the screenshot above is the function which is activated once a day, and code below is the list of all information. The function name is send all data, so you can see which information is collected. So there is system info, contacts, installed applications, call logs, and SMSs. For Telegram channel, we can display some metadata about the creator, the username, and also language used. So in this case, you can see language called FA, which stands for Farsi. So this can give us a hint where the threat actor might be based, but of course, this information can be fake. Now let's move to the last and probably the most interesting threat actors we have recently analyzed. It's called SLUB, and it's targeting some victims who have interests in North Korean issues or in North Korea. So for SLUB, we observed few versions. So we start with version number 1. The name SLUB was given by letters SL and UB. So in the first version, it used Slack, that's why SL, and GitHub, it's like UB letter. So first, the malware sends request to gist GitHub to get command. Command is then processed, executed, and the result is uploaded to Slack. And bigger files are exfiltrated to file.io service. So we know that this version 1 is delivered via waterholing on websites related to North Korea. Then when it reads the gist snippet, it looks like this. So there is a list of self-explanatory commands like exec task list is listing currently running processes, capture is for taking screenshot, drive list is a list of disks, and file list is a list of files in given directory. You can see that there are like two symbols, like caret symbol and dollar symbol, and they decide which commands are activated and which are not. So in this case, only capture command is activated. For Slack, we need a token, and this token was split into several small strings, which have been then concatenated together. As you can see in this screenshot taken directly from C++ binary. Exfiltration to file I/O is also very useful for threat actors because the file gets uploaded, then the link gets generated, and they send the link to the Slack channel. File I/O has like one feature: when file is downloaded just once, then it gets automatically deleted. So this was version 1, but version 1 had some disadvantages, and the biggest disadvantage was that the gist GitHub file was shared between different victims. So the list of commands have been executed by all the victims, which is not very practical solution. So in version 2, GitHub was not used anymore. Instead of that, they relied only on Slack. So they created Slack workspace. In this workspace, there was channel for each user named username minus computer name. And then when a command needed to be executed, it was created a message. This message was pinned in the channel. Then infected machine reads this pinned message, executes it, and writes the result of the executed command into their specific channel. So again, in the schematics, Slack is for CNC communication, for sending commands and sending results of executed commands. File I/O is used for exfiltrating bigger stolen files. And there is also like one more feature. It's like pen.io, which is microblogging service, and this service is used for updating Slack tokens. So if Slack tokens are reported and disabled, then threat actor might publish new tokens here on this website. And if this happens, the malware finds these keywords like hello, what, and 3 exclamation marks, parses the new tokens, and update new tokens. So in gist, when we come back to version 1, so in gist we can see this history. And history tells us which commands have been activated and when. And also it gives us some overview like which files the malware operator might be interesting. So in this case, you can see that there is a software called Plusboard, which is BBS Bulletin board system used in Korea. Again, we have Slack API, we have Python libraries, so we can import Slack client, and if we know token, we can call functions like list users, list team information, list channels, show channels info, show channels history, which is the most interesting for us. The channels history is in JSON format, and you can see the text attribute containing the commands executed by the malware operators. Also, we can get links to screenshots, which we can later download, and we can also display. So this is like one example of the screenshot which we found. You can see that there is some text in Korean language, so likely this victim was based in Korea. So after seeing all this, after publishing our research, what happens? What's the attacker's reaction? So in case of Operation DRBControl, we published the report in February 18th. In March, we found that type 1 payload had a new API key, and also attacker changed the privilege to remove read permission. So we couldn't read the content of the directory anymore. Therefore, SLUB, a few weeks after publishing our report, the attacker changed from Slack to Mattermost, which is similar but self-hosted Slack alternative. So they had no more problem with disabling Slack tokens. So now we are coming to the conclusion. So the abusing cloud service providers is a worldwide trend, as we have shown that there are being different threat actors from all around the world. These services can be used for different purposes. They can be used for store data. They can be used for sending and receiving commands. They can be used for storing configuration. It has many benefits, not only for attackers, but also for us, defenders. So we don't need to hack back. We can just collect some information. We can track attackers in a different way, and in some cases, a little bit easier. So if you are interested in more about our research, you can check some of these references. These are the references of the white papers and blog posts we have done in the past. Thank you.